And I would like to know why you can never get to the end of a rainbow.
The worst disaster in Iowa.
What are your top 3 movies that involve weather?
Welcome to Weathered Questions, where we answer the questions on your radar.
Alrighty, welcome in everybody to yet another episode of Weathered Questions. This one is going to be a little more like our typical episodes of Weathered Question. Thanks so much for indulging us last week as we talked about misinformation. If you missed it, you can go back and listen to it as well. But this week is going to be all about some questions and answers, which is what all this program is all about. And a reminder, we always encourage you to submit your questions. We're going to be getting to an emailed question this episode, and that email came in at weatheredquestions@gmail.com to join up here with our conversation. We're getting towards the tail end of February now. We're knocking on the door of March here in less than a dozen days, and we've got our cloud of the week that is back. Jan, tell us all about our cloud of the week this week.
Yeah, so this week we're talking cirrocumulus clouds. So we talked about cumulus clouds a couple episodes back. You'll remember those are the little puffy cotton ball clouds. Well, anytime you put cirro or cirrus or something related to that in front of a cloud name, that's going to refer to a cloud way high up in the sky, as you'll remember cirrus clouds are. So when you have a cirrocumulus cloud, those are going to be our very high level clouds that still resemble those little puffy cotton balls. But because they are so high up, they're going to be more made out of ice crystals, a little less liquid moisture with those. And so by nature, they're going to kind of be a little closer together, grow a little closer together, be a little thinner in nature. And oftentimes they'll create kind of like rows of those little cloud puffs. And so something you may have heard people reference is a mackerel sky because of the fish. Somehow it kind of looks like that, right? So if you're picturing something in your head of, oh, a mackerel sky, I know what that means. Or if you understand, if you've seen a fish and you've kind of seen those little layers, those rows, and you can kind of picture if that was up in the clouds, then you can kind of get an idea of what a cirrocumulus cloud looks like. One of the things in meteorology that we reference, if you hold your arm out, I'm doing it here, like you can see me in the studio. If you hold your arm out up to the clouds at arm's length and have like your thumb or a finger up there, those clouds are going to be smaller than your finger because they are, again, so high up and so small in nature. So that's another way you can kind of tell the level of the clouds, as well as by using, context clues based on that. And that's going to be the adult hand and finger. Obviously, a kid's finger is probably going to be a little smaller. So just a couple fun little facts about cirrocumulus clouds. Again, that's one of our subsectors of cumulus clouds, just the high up ones.
Sometimes if they get hit in the sun just right, they make some really nice colors too.
They do, yes.
Sunrise and sunset, especially vibrant.
Yeah. Yep. We can get some pretty cool stuff. And especially when you have like multiple layers of clouds, right? Like not only the cirrocumulus, but you have different altitude layers that are going on. You get some really cool colors going on.
Oh, definitely. Yeah, for sure.
Yeah. All right. So that's our cloud of the week, cirrocumulus.
Perfect.
All right, Kai. We're going back now in time a little bit. Back in episode 3.8, we talked a lot about wind and how that kind of changes throughout the day and such. And we got a follow-up question to that one. Somebody kind of comparing how when wind dies out at night, and they said, is that how sea breezes work? So what do you have to say to that?
So sea breezes and land breezes are connected kind of in their own ways. The situation, though, is such that the sea breeze versus the land breeze, we'll talk about sea breeze first. So what happens is you have a body of water, and we know that this water body is not going to change temperatures very quickly. We know this because of how much energy it takes to heat up a swimming pool. And if you make your own little pool in your backyard and you try and have some fun with that, you realize quickly that you need to let it set out for, a couple days before it actually gets inhabitable. Otherwise, you're going to freeze when you go in there. So let's just say that the water temperature is 70 degrees, right? And let's just say we're around Lake Michigan, just for the fun of it. We'll call it a sea breeze, but let's just call it a lake breeze for the fun of this, just because of geography. And we have, infinite bounds there in the water, and then it hits the coastline and we have a definitive stop. So here's what happens. It's a September day, and it's a heat wave. And we get down to 65 degrees that morning. The water temperature is 75. It's a balmy 75 in Lake Michigan. I know it's not very, very common, but it's balmy. All of a sudden, what happens is the sun heats the ground and the ground heats the air above it. That's how we get our daytime highs. The ground is going to respond very quickly. The water is going to stay exactly the same. It's going to stay at 75. And so all of a sudden we're heating. And then we hit about 90. And then that air parcel rises. Well, what's going to replace it? The cooler, denser air over the lake comes down and out, and it creates a little breeze. It's like an everyday afternoon cool down is what you wind up seeing. Down in Florida, because of the high humidity, this actually yields thunderstorms quite often. You can see this about the 2-3 o'clock in the afternoon, 15-minute thunderstorm that comes through the region. That's the science behind it. The air comes in, it converges with existing air, and then boom, you wind up getting some sea breeze thunderstorms going on. The opposite then occurs at night. So everything starts cooling down and the reverse process happens. So it really has to do with the density of the air over the cooler water, at least relatively speaking, compared to what's going on outside. Now, if it's an overcast day and the temperatures are the same, it's like 75 on land, 75 over the water, there's no difference. The air density is not going to change, and so it's going to be all uniform. You're not going to see that sea breeze go on. What I've always found very unique about that, and when it does come in, is we're always kind of born and raised, especially in the center of the country, that south winds are warm. Yeah. Until you get to northern Michigan or in southern Canada, when all of a sudden a superior south wind is dang cold. That's darn cold, man. So you have a heat wave in Canada.
Summer in Duluth,
boom.
And they refer to the lake as the built-in air conditioner.
It is.
Because, any air coming off the lake is so much cooler. And I mean, if you were forecasting for by the lake and up on the hill in Duluth, like you literally had two forecasts. One by the lake, one up on the hill for the same city, because it would be a 10-15 degree difference.
Well, and I never wound up doing good research on this. All I did was observational stuff. Never actually had a chance to really study it very well. But I have always kind of held the contention that peak ice coverage on the Great Lakes equates to a cold start to spring for the adjacent states, because any northeast wind that comes off that lake, especially if there's still ice coverage there, that has an effect on how far north the warm fronts can go. And I will tell you that if we have a strong northeast wind that flows off Lake Michigan and Wisconsin, Illinois, Indiana, and out towards Iowa, and you are expecting warm temps in April, you will bust. It will happen. People will be upset with you. So aim low. If you see a northeast wind in April, aim to the lowest possible model guidance you can. If there's any budding meteorologists listening right now, I'm telling you right now, it'll bust you. Now, in the fall, it's not as big a deal because the water's been warmed up all summer.
Yes.
But when you're coming out of winter, and especially the ice coverage we have this year, Great Lakes are pretty ice covered. So I would expect a couple of those sneaky northeast winds this year.
Ice. Mm-hmm. Yeah, it's like if you open a cooler of ice, you can feel that cold air coming off of it for a distance. It's like that. There's just a big cooler of ice up on the Great Lakes, and that colder air kind of emanates.
Yep, they've been cold this year in northern Michigan, much of the Great Lakes states. Erie has had a whole lot of ice cover. It had that big crack form in it a couple weeks ago. That was neat to see on satellite. So it's been covered pretty heartily now for a while. So it's going to take a while for the lakes to warm up this year. It might be a cold Michigan trip for me this year, Jan. And I promised the girls that we're going to go parasailing.
Yeah, how you doing on that? Got to update everyone.
Well, it's going to maybe the water is going to be colder now because of this amount of ice coverage we've got, and I've been told that our trip is going to be 2 weeks earlier. So all the more reason to get ready to freeze when I go up there. So we'll see. We'll see how it goes.
Oh, well, hopefully things warm up, but obviously not too fast, right? Yeah.
It's shockingly refreshing to jump in a pool of cold water. I know it sounds uncomfortable right now, but it seriously is.
I don't know. I've never been one for like, the ice baths and everything. I would much rather be in a warm, or not even warm, just 85 degrees.
Can always
like
try it
normal
once.
pool temperature.
Never hurts to try it once. Always go
That's
one
true.
time.
Right.
You can.
Convince me, maybe. We'll see.
Yeah.
Well, speaking of cool ice and such, and as we're looking ahead, hopefully, things start warming up and we're looking towards more sunshine, warmer temperatures, all of that coming our way here. But right now, today's trivia question, it kind of circulates around what our sunshine compares to in other parts of the year right now. So it's a true, or not a true false, sorry. I don't know why I said that. It's a multiple choice. That's the word I want. Multiple
1 out
choice.
of 3. It's okay.
It's a ABC question. We'll say that. All right. So we get the same amount of sun in late February as when? Is it A, late October, B, late November, or C, late December? So how much sunshine do you think we get in late February compared to what other month? Same as late October, late November, or late December? We'll give you a couple seconds to think about that one, and we'll give you the answer in just a bit. All right, so again, that question was, we get the same amount of sun in late February as what? A, late October, B, late November, or C, late December? I know you used to always love asking this kind of question for your morning trivia question for several years, because I think people get very surprised when they realize that we get the same amount of sun in late February as we do in October.
Mm-hmm. Absolutely. Oh yeah. And when you're snow free this time of year and your frost depth isn't very deep, or maybe you don't have any frost, you can get a tremendous warm up in February and March. You really can. This year may be a bit different, but we'll see.
Yeah. Think back to October, right? We can have plenty of warm bursts into November, into December, right? But October can be fairly mild. Obviously, yes, you can also get snow, just like we can in February, but as Kai noted there, if we don't have snow on the ground, it can be very mild, very, very easily for us in terms of actual temperatures, and that sun angle only helps to facilitate that because we're getting more sunshine, more daylight, and that sun angle also really plays into, before too long, those of us pasty folks are going to need sunscreen much more regularly because it can really catch up on you if you're not wearing long sleeves and you're out doing yard work or something. Come March, it can start getting to you.
Well, and some of those cold, sunny April days too that we have, if they're sunny in April, you're talking about the same sun angle as June by that point. And if you're sitting outside or just trying to get some chores done and it's a cool 40-degree afternoon, you would think, right, that the sun wasn't that strong, but it actually is. So just something to think about here in the next few days. We have a question, though, that came into the inbox for us. This came in from Tim Gilbertson, and we're kind of keeping the sun theme going here. So Tim says, "Hi, Kai and Jan. I have a question that's been bugging me for a while. It's only sort of weather-related. That's okay. How come since January 1, the sun sets 28 minutes later, but the sun rises only 10 minutes later? Shouldn't it be equal? Thanks, Tim." Well, Tim, you'd think it'd be equal, but it's really not. The problem is something called the equation of time. It's extremely complicated, and it's extremely convoluted. But the issue comes in here to where solar noon is every day. So solar noon is at the time of day when the sun is at its highest. As much as we teach people that we're going perfectly around the sun, we're not. We go in an elliptical pattern. So as a result, the tilt can kind of be a little bit little bit different too. And so what happens is our solar noon adjusts a little bit later, and it adjusts a little bit later than the sunrise does. And so what it does as a result is it pushes the sunrise a little bit later. It's not a drastic change. For those that look at it, such as what you did, minute by minute, there is a difference. A lot of times we can kind of just say, okay, it's approximately the beginning and end, and it's close. But as you accurately noted, it's not. There's a difference there. And so it's the equation of time. There's a lag there, and it's mainly because of the elliptical orbit that we're in as opposed to anything else. But we see it. We also see it in the fall as we go into winter as well. It's just not the same on each time of day. The equation of time, I don't recall off the top of my head. I believe it is an impossible equation that is spooky and scary. But that's what's going on with that question right there, Tim.
I just pulled up equation of time. I pulled up the Wikipedia just because I was curious. And there's a lot of fun graphs and
but it does have to do with that orbital path that we take.
If you're curious.
Yeah.
It does.
And you think about also, we take the same kind of path that the moon takes around us. There are times that we're closer to the sun. There are times that we are farther away from the sun. And so if we're spinning on our axis, but we're also not a perfect distance from the sun at all times, that's going to adjust. And it's most notable in the cold seasons, in the close to the transition points, I should say. But when we're farthest out like that, yeah, there's going to be a little adjustment there between when it comes up and when it goes down. So it's not totally equal on both sides of the day. Much like the equinox is not this, it's not necessarily the same everywhere, even though you think equinox, which is going to be for another show. But that's another one where it trips people up quite a bit about the equinox.
And I think it's important also to note there that time is a human construct, right?
Mm-hmm.
Like
right.
The solar noon,
right.
Maybe confusing because we call 12 noon, but solar noon is a actual thing, right? That always is not at 12 p.m. Because of daylight saving and because because of so many things, right? But time is a human construct, and the planets are not following that. The calendar, our clock, all of that is just stuff that we have developed in order to help us as humans function and keep up with each other and, have a functioning society. But it's not, the sun doesn't care what time it is. Right. The sun is going to come up when the sun's going to come up.
Yeah. And the noon concept is literally its highest point, or kind of its halfway point, close to its halfway point of the day, if not right on. And so it shifts every day. It does move every day. When it's the highest possible in the sky. And you would think, because it's probably going to be, it's supposed to follow a perfect parabolic curve until it doesn't, because we take an elliptical path. If we took a perfect circle path around the sun, then it would be very predictable. The beginning and the end would always, build out by a minute each time, or close in by a minute each time, or whatever increment we want. Because it's elliptical, it gets off. Gets off at certain times of the year. Now, if you go to timeanddate.com,
I have it pulled up right here. Actually.
You can go through there and you can figure out what times of the year that you see this lag going on. There are some times of year where it is +1 on either side. Mm-hmm. But once you start getting to this time of year especially, it is a little offset. So good, accurate observation there from Tim. And I agree. It's weather related. It's definitely weather related. Yeah. For sure.
Yeah, absolutely. And just to clear anything up, if anyone is confused, like the fact that we are still gaining daylight or losing daylight after an equinox, that or solstice, that is still occurring, right? We are still right now in February, going into March, going in April, we are gaining about 2.5 minutes of daylight every day. It's just not equally distributed across the sunrise sunset time frame. Those sunsets are getting later, those sunrises are getting earlier, just not as quickly earlier as the sunsets are getting later.
Yes.
there's hopefully everyone followed there.
Well, as you can see, it's not the easiest thing to explain.
No, it's not.
It's a tough one.
It's not intuitive.
No, it's really not.
So hopefully that cleared some stuff up for you, Tim. Thank you for your question. Again, if you would like to send us an email or a recorded question, you can do that at weatheredquestions@gmail.com. We would love to help answer whatever is on your radar and help get that answered. All right, we have a couple more minutes, guys. So we're going to dive into one more question today. This one revolves maybe also not truly weather related to some people, but it really does play a lot into why our weather is the way it is, especially on the west coast of the U.S. ocean currents. And we kind of dive into why big weather makers might move into places. This was actually a conversation that I had with some coworkers. They were asking about the climate of San Francisco and why it was the way it was. And they were trying to argue that maybe it was because of the latitude of where it was. And I was trying to explain that it was actually ocean currents and the marine layer and stuff. You know, we just dove into a little bit of sea breezes, land breezes. And so we talked a little bit about how water in, you know, just a lake or something like that, how that can have an impact. But when you have a giant swath of water like the Pacific Ocean, that really plays a factor in as well. So you want to talk a little bit about ocean currents or, you know, why that plays into California a little bit?
Well, we've got the ocean currents that are there, and a lot of these are semi-permanent that show up. They do oscillate back and forth occasionally, but a lot of them are semi-permanent. They don't go very quickly. And so as a result, there are some predictable aspects of this that we can find. One of the most common ones that we see, aside from getting into the whole El Nino, La Nina stuff, is so there's been a number of names for this that have come out in the past. One of them is Pineapple Express. Well, it's not technically a real weather term. It's more of a nickname for an atmospheric river that comes from Hawaii to about southwest Canada and the Pacific Northwest. And because it goes through the Hawaiian area, they consider it Pineapple Express because there's pineapples there. And so, I mean, that's the only reason I can think about how they've connected the two.
Yeah, I think so. I think you're right.
But usually there's a low pressure system. Occasionally that low is going to be up in the Bay of Alaska. And then on the southern end of that low is when that jet stream is really screaming. And what happens is that is a big moisture transporter. A lot of times we think about the center and eastern sides of the U.S. being influenced by the Gulf down south. Well, central Pacific moisture moves too. And when that gets moving in the right direction and it collides with some elevation, such as mountains, we wind up getting some tremendous rains. In the last few years, you can go back and take a look at some tremendous rain in Washington. Washington State in 2025 had huge amounts of rain, thanks to an atmospheric river. Vancouver, Canada has had several big rainfall events in the last few years too. So it can definitely happen. Sometimes they're a blessing, quite frankly, because California will get involved in these long, persistent, severe droughts. And all of a sudden, an atmospheric river comes in and gets it all back to normal again. And I believe there was a stat that it was either late 2025 or early 2026 that California was finally drought-free, which is great news.
Yeah.
Because I know that sometimes it comes with flash flooding and all of this stuff, but at least the moisture is back. And that's I think, the biggest thing about atmospheric rivers.
For the
now,
same
there are
reason,
some
though,
warm
that,
spots, but it's mostly pretty chilly out there.
For the same reason that can perpetuate that, though, you know, if you're not getting that atmospheric river bringing in all that moisture, then it's very difficult to get moisture into the area, and then you can just continue to get a drought. So again, if everything in weather ebbs and flows, right? If you're getting your weather moving in from that moisture rich area, you're going to have more of that rain. But if the pattern is such that it's not, you're going to continue to have that drought, and that can perpetuate things. That is why California can get so well entrenched into that drought situation as well.
Yep. Well, and when the Pacific isn't quite playing nice with you, then it becomes an awful big issue. It can be very persistently dry or persistently wet. There doesn't seem to be a middle ground currently with that situation. So that's what you wind up hearing about. And those atmospheric rivers are out there. They've been around forever. We're getting them more involved in what seems like the news cycle more and more lately.
Yes.
We definitely hear more about them. Yeah, right,
Yes.
right. We definitely hear more about them.
Yeah.
So
It's with a lot of weather events. Once people
Mhm.
understand the name or the terminology, they kind of pay more attention to them and then say, "Oh, is this?" And it's like, "Well, yeah,
Yep.
we've always had that. We're just now you know what to call it. Now you know
Right.
how to recognize it, right?"
Yep, absolutely. You got it.
All right. Well, that brings us to the end of yet another episode of Weathered Questions. Thank you again so much for spending some time with us here and learning about weather and letting us teach you about the weather. We truly do enjoy it. As a reminder, you are always welcome to join the conversation. Let us know what is on your radar. weatheredquestions@gmail.com. Email us, send us an audio question, send us an anonymous question, however you want to join the conversation. We would be happy to have your questions. Until next week, stay safe.